This video is going to cover Chapter 1, Section 6A, which is the first part of Chapter 6. Of Section 6, which is solving other types of equations and polynomial equations. So we're continuing with solving equations. Some of these things we have seen before, and some of them are going to look a little differently today. We start by just the general of solving polynomials. So when you're going to look at an equation and you're going to look at these, and you're going to start with, can it be factored? Just like we used to do if it was quadratic, we would look and see if it can be factored. This time it also can be higher than just squared. So you might have factor by grouping, or you might have something to the fourth power, but it still means it can be factored. So you're looking to see if that is not prime. And as usual, you always want to start by factoring out the greatest common factor. And then if there's a variable in the first term is the square of the middle term, then you can actually use something. We're going to use the substitution model to make these a lot easier to solve. So when we get to those, I'll point that back out again, but that is something that we're going to do today that is new. If the middle term is the square root of the first term, or the first term is the square of the middle term, then we're going to use substitution to make those a little bit easier. Okay, so we start with something that hopefully looks relatively familiar. These are x to the seconds. So now we've thrown in x to the fourth. That would be different about these than what we've been doing. But as soon as you see two different x's, so like an x to the fourth and x to the second in this case, it should be your hint that you're going to have to get everything to one side. So if you don't just have a single x that's raised to a power where we would do the even root property, then you're moving everything to one side, and then we'll go from there. So the first thing I'm going to do is subtract this 48x squared so that it's equal to 0. And I get 3x to the fourth minus 48x squared equals 0. Then your next check should be, can I factor something out? So when I look at both 3x to the fourth and 48x to the second, is there a number that goes into both? And is there a variable that goes into both? Hopefully you caught that the answer is yes. 3 goes into both of these, and x to the second goes into both of these. So you would do the lower power because that would be the common factor. So by taking it out, we're going to divide both of these by 3x to the second. And I end up with x to the second minus 16. Now, what we can't do with that is divide each of the terms by 3x to the second and cancel them out, because you're actually losing one of your zeros. So whereas when we did complete the square, we divided everything by a numeric value, so just a constant, you can do that. What you cannot do is get rid of that x squared. So I could divide both sides of these by 3 and get rid of the 3, but I can't lose the x squared because that means that there's another answer there. All right, so now I'm going to do my two things. One is I can take the x squared minus 16 and factor it further, or when I split and solve this, because if either of those is 0, the whole thing is 0, I can actually split that up as x squared minus 16 equals 0 and then use the even root property. Because we're practicing factoring, I would say let's take it to the next step. So 3x squared, and then x plus 4 and x minus 4. And each of them is set equal to 0. So there are three terms, or three separate terms being set equal to 0. The first being 0 equals 3x squared. And if I divide both sides by 3, it goes away. 0 equals x squared, and then I square root both sides, and plus and minus 0 is still just 0. Now, it's important that there are two of them there. In the long run, when we get to graphing, that's going to be important, but for right now, we just need the 0 once. Then I go to the second one, x plus 4 equals 0, subtract the 4, and x would equal negative 4. And then I go to the last one, x minus 4 equals 0, add the 4, and I get x equals 4. So there are three answers here, negative 4, positive 0, negative 4, 0, and positive 4. Okay, 2 is very similar, except it's already set equal to 0. I didn't have to move anything. I'm looking at both of these terms. This time they are both divisible by a 3x squared again. So the 3x squared is coming on the outside. Divide this by 3x squared and this by 3x squared. And I get 3x squared minus 4 equals 0. Now this time I can't factor 3x squared minus 4. That's not the difference of perfect squares. 4 is, but 3 is not. So instead of doing it that way, this time we're going to split and solve from here. So I'm going to set that equal to 0, divide both sides by 3. I get x squared equals 0. Square root both sides of the equation. Again, it would be a plus and minus, but it's 0, so it doesn't matter. That's my first answer. And then go to the other side. 3x squared would equal 4. Divide both sides by 3. You have to isolate that x squared before you can square root both sides, putting the plus and minus in the front. And I'd get x equals plus and minus the square root of 4, which is 2, over the square root of 3. And then we rationalize because you can't leave the square root in the bottom. And I get plus and minus 2 root 3 over 3. So the solution's here, 0, and then plus and minus 2 root 3 over 3, which can be written like that or separated out. Doesn't matter how you write it, as long as you list them all. And pay attention, because if WebAssign wants them separated out and smallest first, then obviously that negative 2 root 3 over 2 would need to come first. But if this is an open-ended question, you can simply write it as plus or minus. Okay, go to number 3 next. It's already said equal to 0, and this time there's 4 terms, so we're going to factor by grouping. I'm going to group these 2 and these 2. From the first set of parentheses, I can take out an x squared, and I get x minus 3. Second set of parentheses, I can take out a positive 3, and I get x minus 3. The x minus 3's repeat, so that comes out as the greatest common factor. And I group together what's left, which is x squared plus 3. And I split and solve, set each of these equal to 0. I get x equals 3. And I get x squared equals negative 3. So I square root both sides. And there's where our complex numbers come back in. So it's plus and minus I, because the i's got to come out, square root 3. So plus and minus I root 3 and positive 3 would all be solutions to this equation. Four is similar to that one. Factor by grouping. There's 4 terms. From the first set of parentheses, I can take out an x squared, and I get x minus 5. Second set of parentheses, I take out a negative 2, and I get x minus 5. The x minus 5 repeats, and the x squared minus 2 gets grouped together. Split and solve here. X would equal 5. X squared would equal 2. Square root, plus and minus, and x equals plus and minus the square root 2. So my 3 answers are plus and minus square root 2 and 5. Okay, on to the next set of examples. When you look at number 5, again, first thing you always want to check for is, can I factor something out? And this time we can. Each of these are divisible by 3, and each of them are divisible by x. So I take out that 3x again. This would be divided by 3x, 3x, and 3x. And here the x cancels. That would be 2x squared. 3 goes into 27 9 times. One of the x cancels, minus 9x, and then 3 goes into 54 18 times, and the x cancels. So now from here, inside the parentheses, we've got something on the front of our term. So we're either going to do first and last or trial and error. I'm going to multiply 2 times negative 18 to do first and last. I get negative 36. Factors of negative 36 that sum to negative 9 would be negative 12 and positive 3. That 3x is going to stay on the front, but then in parentheses, I'm going to replace my middle term with negative 12x and positive 3x. And then I'm going to factor by grouping what's inside the parentheses. That 3x is still on the front, and I don't want to forget about it because I need it at the end. From that first set of parentheses, I can take out a 2x, and I get x minus 6. Second set of parentheses, I can take out a 3, and I get x minus 6. Now what's inside the parentheses here is your greatest common factor. 3x is still in the front, but then I get x minus 6. And then I group together what's left, the 2x plus 3. And now there are 3 separate equations to set equal to 0. Divide by 3 here, and I get x equals 0. Add the 6, I get x equals 6. Subtract the 3, divide by 2, and I get x equals negative 3 halves. So 3 answers again, negative 3 halves, 0, and 6. Okay, so now these next set of equations kind of change a little bit. And we have done these, it's been a little while since we factored this kind. But when you have an x to the 4th on the front and you have an x to the 2nd in the middle, you want to factor them into their 2 sets of binomials. But instead of it being x only at the front, it's going to be an x squared. So really, to see if they're factorable, we're going to ignore the x to the 4th and the x squared at the beginning and just look at the term at the end and the term in the middle and see if there are factors of positive 2 that sum to negative 3. There are. It would be negative 2 and negative 1. So then when I set up my 2 sets of parentheses, instead of it just being x at the front like it normally is, this is x squared. So it would match that middle term. And then what's left is the minus 2 and the minus 1. This whole thing equals 0. So if either of these equals 0, the whole thing is 0, which means we can split and solve from here. You can also take the right side and factor that further, but we're going to use the even root property. On the left, I get x squared equals 2, and x would equal plus and minus the square root of 2. On the right, x squared equals 1, and x would equal plus and minus the square root of 1, which is just positive and negative 1. So now I have 4 answers, negative root 2, positive root 2, negative 1, and positive 1. If it was open-ended, you could have written it as plus and minus root 2 and plus and minus 1, but if it's like on WebAssign or if it's written out in multiple choice and it's separated out like that, you would want to write it that way. All right, 7 and 8 are pretty much the same, except that with 7, it is the same. 8, you're going to have that term on the front, so it's one step more. So for 7, again, we're ignoring the we're ignoring the variables for now, and we're just looking to see if there's factors of positive 12 that sum to negative 7, and there are. It'd be negative 3 and negative 4. So I set up my 2 sets of parentheses, and instead of it being x, it's x squared. So x squared minus 3, x squared minus 4 equals 0. Split and solve this. I get x squared equals 3. X would equal plus and minus the square root of 3. X squared equals 4, and x would equal plus and minus the square root of 4, which would be positive and negative 2. So I get plus and minus root 3 and plus and minus 2. Now 8, in the beginning, I'm going to ignore the x squared and the x to the 4th, but there's a number at the front this time, so I need to do my first times last. So 9 times 4, are there factors of 36 that sum to negative 37? Answers yes, negative 1, and negative 36. So now when I plug in for my middle term, where before I'm going to factor by grouping, I'm going to leave the 9x to the 4th on the front. But my middle 2 terms each have to have the x squared. So it would be minus 1x squared and minus 36x squared. And then plus 4 at the end equals 0. Now we factor by grouping. First set of parentheses, I can take out an x squared. And I get 9x squared minus 1. Second set of parentheses, I can take out a negative 4. And I get 9x squared minus 1. Now what's inside the parentheses is the same, so that's my greatest common factor. And what's grouped together, or what's left gets grouped together. So now these are both factorable. I can actually keep going, or I can use my even root property to solve. So let's factor them, because this is the difference of 2 squares, 3x plus 1, 3x minus 1, and this is the difference of 2 squares, x plus 2, x minus 2. Set them each equal to 0. And I get a negative 1/3, a positive 1/3, a negative 2, and a positive 2. And those 4 are the solutions for this equation. Okay, so now we've got a couple other different types. Number 9 brings back in our rational equations. So this is when we've got a variable in the denominator. So not only do we want to get rid of that variable, which is what we did at the beginning of 1-4, or 1-2 actually, we also have to check for our restriction. So because there's a variable in the denominator, I would say x squared cannot equal 0, which means x cannot equal 0 at the end. If it is 0, we're going to rule it out. That's called that extraneous root. But I want to get rid of those. So I'm going to multiply everything by x squared. So I get 1 times x squared, or x squared, plus this times x squared. One of those cancel out, 3x. This times x squared, both of them cancel, and I get -2. Now I want to get everything to one side. And then, are there factors of +2 that sum to 3? It'd be +1, +2, and I split and solve -1 and -2. So hopefully that's just a refresher, because we definitely did stuff like that in 1-2. And then obviously you want to make sure that you're checking that neither of those were 0, which is why we kept both those answers. Okay, so 10 we did already, where we would find the factors of 2 that sum to -3, but we're going to use another method, so you have another option, which is substitution. So for these, if the first term is the square of the second term, as far as variable goes, then you can do this process of substitution. I'm going to take whatever the variable is with its exponent on the second term, and I'm going to substitute a variable in for that. So we're going to use a. We're going to say a equals x squared. So where there's an x squared, I'm going to put an a, which means x to the 4th would be the same thing as x squared squared. And that means my first term is actually going to be a squared minus 3, x squared we said was a, so 3a, plus 2 equals 0. And now this should look something much more familiar to us. We're just going to factor it. We're going to find our factors of +2 that sum to -3, which is -1 and -2. We're going to split and solve here and get a equals 1 and a equals 2. But we're not done yet, because a is not what we're solving for. X is what we're solving for. So in place of the a's here, I'm going to come back and put what we substituted a in for. So x squared equals 1 and x squared equals 2. And then I square root both sides, putting the plus and minus in front of the 1. And I get x equals plus and minus 1. Square root here, plus and minus, and x equals plus and minus 2. Root 2. So it's just another way of doing that same type of question we did before, but using a different method. I would say it's up to you how you choose to do these, but moving forward, you're going to see a couple different kinds of questions in which you're definitely going to want to substitute. But with the x to the 4th and the x squareds, I would say do what you're comfortable with. Either go back to the method like we did before in examples 6 through 8, or use this method. Okay, so something like this, and these look so much scarier than they're going to be, but these are ones in which you're definitely going to want to do substitution. So the test to see if you can do substitution is look at the variable term on the second one. Now this time it's this whole expression and the first term. And is the first term the square of the second term? So 1/3 squared, when you raise a power to a power, we multiply it, would be 2/3. And because that works, then this means I can use that substitution process. So I am going to replace x plus 1 to the 1/3. Whatever that middle term is, I want to replace with a. So my first term is just going to be a squared, minus comes from the middle. There's no coefficient here, so it's just a, minus 2 equals 0. Now I'm going to factor this. Factors of -2 that sum to -1, minus 2, +1. Split and solve it. And I get a equals 2 and a equals -1. And then substitute a back in. So x plus 1 to the 1/3 equals 2, and x plus 1 to the 1/3 equals -1. Now to get rid of a 1/3, we're going to raise both to the 3rd power. And I'd get x plus 1 equals 2 to the 3rd, which is 8. Subtract the 1. And x equals 7. Raise both sides here to the 3rd. X plus 1 equals -1. Subtract the 1, and x equals -2. So I get -2 and +7. We're going to save number 12 for tomorrow so I can work through it with you. I know these are probably the hardest ones to do, so just make the best attempt you can on tonight's WebAssign, and we'll review them again tomorrow. The same kind of concept can be done in different ways. For example, 13-14. So even though, again, these look super complicated, we can use that same process. So if you look at 13, this middle term is being squared on the front, which means I can substitute in. So I can say that x over x plus 1 equals a. And I can make this 6a squared plus 5a minus 6 equals 0. And now I'm going to factor. I'm going to do 6 times 6, or 6 times -6, which is -36. Factors of -36 that sum to 5 would be +9, -4. Replace the middle term with those two. And factor by grouping. Take out a 3a here, and I get 2a plus 3. Take out a -2 here, and I get 2a plus 3. Then the 2a plus 3 comes out, and the 3a minus 2 gets grouped together. Split and solve these. Subtract the 3. Divide by 2. Add the 2. Divide by 3. And that's what a equals. So we have to plug back in what a equals. So -3/2 would equal x over x plus 1. And 2/3 would equal x over x plus 1. And then from here, we cross multiply is the easiest way to solve these. -3 times x plus 1 equals 2 times x. Distribute the -3. Add the 3x. -3 equals 5x. And divide by 5. X equals -3/5. Same thing on the other side. Cross multiply. 2 times x plus 1 equals 3 times x. Distribute the 2. Subtract the 2x, and 2 equals x. So my two answers here are -3/5 and +2. Because there's a variable in the denominator, we want to make sure neither of those are 0, so x could not equal -1 there, which means both of these answers are okay to keep. All right, we're going to save 14 for tomorrow. I'll do that one with you. So please take a moment to submit your notes so that you can get your classwork credit for the day. And you can begin to work on your 1.6a homework. Have a fantastic day, guys, and I'll see you tomorrow.